the previous chapter, we have discussed about how we are going to use the coordinate system and map projection in GIS, and how it will be easy for us to take the data or to find a query in the GIS system based on the coordinate system or based on the map projection. In this chapter, we would discuss about the different components of GIS. Objectives. In this chapter, we will understand about the different components of GIS, that is hardware, software, data, methods, people, network. Components of GIS. There is almost as much debate over the components of a GIS as there is about its definition. At the simplest level, a GIS can be viewed as a software package with various tools to enter, manipulate, analyze and output of geographic data. At the other extreme, GIS components include the computer hardware, software, spatial data, data management and analysis procedures, and the peoples to operate it. If the computer is located on a network, it can also be considered as a component of GIS, since it enables data sharing among users. Hence, GIS is the combination of all these 6 components organized to automate, manage and deliver information through geographic presentation. The 6 parts of a GIS are hardware, software, data, methods, people and network. Previously, there were only 5 parts to a GIS. Network was later added with the advent of widely used internet. Hardware. Hardware is perhaps the simplest part of a GIS to explain. The hardware is the computer on which a GIS operates. Today, GIS software runs on a wide range of hardware types, from centralized computer servers to desktop computers used in standalone or networked configuration. Hardware components. The hardware components of a GIS consist of a computer, a memory, CPU or workstations, data storage devices, tape drives or others, scanners, digitizers, plotters, printers, global positioning system units and other physical components. The user controls the computer and the peripherals via a visual display unit or terminal. The disk drive unit provides the space for storing of map and document data in a digital format and sends them to a computer. The plotter used to present the results of the data processing. A tape or CD, DVD drive is used for storing data or programs. A scanner or digitizer is required to convert the analog data into digital format. Computers should have essentially an efficient processor to run the software and sufficient memory to store data. The size of the computing system will depend on the type and nature of the GIS. A small scale GIS will only need a small personal computer to run on, while a large enterprise-wide system will need larger computer and a host of client machine to support multiple users. The essential hardware elements for effective GIS operation include the presence of a processor with sufficient power to run the software, the sufficient memory for the storage and backup of large volumes of data, a good quality, high resolution color graphic screen or monitor, and data input and output devices like keyboard, printers and plotters. Software. GIS software provides the function and tools needed to store, analyze and display geographic information the core of any GIS system lies in the GIS software itself, providing the functionality to store, manage, link, query and analyze geographic data. In addition to the core, various other software components can be added to GIS software to provide access to additional sources of data and forms of functionality. Imaging system used to analyze satellite imagery, database management system used to store additional sets of data and CAD system can all be integrated into a GIS solution, provide the data and full functionality needs of the GIS. The key software components are support geographic query, analysis and visualization, a geographical user interface GUI for easy access to tools. Data, possibly the most important component of a GIS, is the data. The geographic data and related tabular data can be collected in-house or purchased from a commercial data provider. A GIS will integrate spatial data with other data resources and can even use a DBMS used by most organizations to organize and maintain their data to manage spatial data. Data. The most important component of a GIS is the data. The geographic data and related tabular data can be collected in-house, compiled to custom specifications and requirements, or purchased from a commercial data provider. A GIS can ingest any type of data in many different types of format. The ability for a GIS to consume such a wide range of data can often produce the effect of the data overload. With the wide proliferation of sensors, data collectors, there is more data available to us today than ever before. With so much data, it is often difficult for a person to easily understand what the data actually is, as if it's useful. A GIS can visualize the data as a map, graph or other graphic that helps humans understand and weed through massive amounts of data. In fact, the problem of too much data does require a GIS user to spend quite a bit of time managing the data. In general, half of all the time spent on a GIS project will simply be working with and preparing the data for maintenance, storage, analyze and output. A GIS can integrate spatial data with other existing data resources often stored in a corporate DBMS. The integration of spatial data, often proprietary to the GIS software, and tabular data stored in a DBMS is the key functionality afforded by a GIS. Data for a GIS comes in two forms: geographic or spatial data and attribute of spatial data. Spatial data are the data that can contain explicit geographic location in the form of a set of coordinates. Attribute data are descriptive set of data that contain various information relevant to a particular location. Example: depth, height and sales figures, and can be linked to a particular location by means of an identifier. Example: address and zip code. The data that a GIS operates on consists of any data bearing a definable relationship to space, including any data about the things and events that occur in the nature. At one time, this consisted of hard copy data like traditional cartographic maps, surveyors' logs, the demographic statistics, the geographic reports and the descriptions from the field. Advances in spatial data collection, classification and accuracy have allowed more and more standard digital base maps to become available at different scales. Sources of spatial data include paper maps, charts, and drawing scans or digitized into the system. Digital files imported from CAD or other graphic systems coordinate data recorded using a GPS server and data captured from satellite imagery or aerial photography. Sources of attribute data include database, workflow, messaging, and any other forms of computer system that stores data sets that can be linked to a GIS by means of a common identifier. Data streams generated by sensors or data loggers of any kind can be stored in the GIS, and that data can be linked to it by means of an identifier. Data from satellite imagery derived through image analysis techniques that can be linked to a location or a set of locations. Methods. A successful GIS operates according to a well-designed implementation plan and business rules, which are the modules and operating practices unique to each organization. As in all organizations dealing with sophisticated technology, new tools can only be used effectively if they are properly integrated into the entire business strategy and operation. The method part of a GIS refers to the formulas, statistics, analysis, and algorithms that are used to turn data into information so that humans can turn that information into knowledge through interpretation. To do this properly, it requires not only the necessary investment in hardware and software, but also in hiring of personnel to utilize the new technology in the proper organizational context. Failure to implement the GIS without regard for a proper organizational commitment will result in an unsuccessful system. It is simply not sufficient for an organization to purchase a computer with some GIS software, hire some enthusiastic individuals, and expect instant success. In fact, the importance the application should not be undermined. From the application, a set of procedures will follow as a means by which organizations solve the problems inherent in the application. The procedures and software requirements will help to define a list of skills required to operate on the GIS functions, procedures, and make judgment. In summary, this component incorporates the functions: methods and procedures of data collection, encoding and storage in the GIS database, methods and procedures of data quality assurance, verification to make sure that all data is correct, consistent, correct and up to date for analysis, methods and procedures for data manipulation and query, methods and procedures of data preparation and transformation of different sources, techniques of data retrieval, operation, analysis, representation, presentation and dissemination, and so on. People. The people segment refers to anyone that uses a GIS. This includes the general public that may be using a printed map or a digital globe, all the way up to skilled GIS professionals that build new functionality and push the limits of what is possible in a GIS. The main objective of a GIS is to support its users with the appropriate data and decision support tools. Thus, careful consideration of particular needs of the users must be given at the design stage of the system, so that each group of users will be given access to the data and functionality of the system in the most appropriate way. A system must be highly accessible and usable, otherwise it may not be used effectively or may not be used at all. Some users need to access to the most advanced functionality feature a GIS offers and are willing to invest the time needed to learn how to efficiently use these tools. Other users only need specific answers to their questions. In such cases, They have no need for advanced functionality and there is no point in investing the funds required to train them. Hence, for maximum utilization of GIS by the users, it is necessary to invest in workstations and training, allowing them to directly interact with the GIS. A careful attention to the needs of each user group will lead to higher utilization rates and therefore a greater return results on the investment in GIS technology. The GIS technology is of limited value without the people who manage the system and develop plans for applying it to the real world problems. GIS users range from technical specialists who design and maintain the system to those who use it to help them perform their everyday work. The identification of GIS specialists versus end users is often critical to the proper implementation of GIS technology. People are the most complex component of GIS. This component is the most failure prone and the only component capable of self-correcting and able to repair other components. People may operate individually or within a group or team. Individuals may function as GIS manager, analyst, technicians or as a user. Almost all should have the basic knowledge needed to work with geographic data, knowledge of data sources, scale and accuracy and software products. Network. Lastly, network refers to both the computer and social network. Both these networks assist in the dissemination of data, where the dissemination of data is through transferring of data sets or collaboration. Sharing the data from a GIS is a very common and useful operation. Additionally, this network allows for the display of information in the form of a web maps, web application or even paper maps using our social network. This network has latest included in the components of GIS with the development of social networking and computer science. This network helps in sharing the data developed by different organizations or people around the globe and also allows us to view different map data sets that are created in the world. Summary. In this chapter, we understood about the different components of GIS where hardware includes all the computer parts that involves in the setup of the GIS, software where it provides the functions and the tools to store, manage, query the different data and the different types of data, that is raster data, vector data and attribute data, methods which include different business plans and organizational setup, and lastly people which include the personnel who supports the GIS operation. Recently, the network is also added into the components of GIS.